Okay, so this is problem 11.5.3, and they're telling us that in tossing two fair coins, they want us to construct a probability distribution for a suitable random variable x and then find the expected number of heads. Okay, and so they're giving us this chart here, and they want us to complete the probability distribution, and they tell us that we're going to let x represent the number of heads. Okay, all right, so the first thing that we need to do is just take a look at the probability of what's happening when you're flipping two fair coins. And so I'm actually going to draw for us, just on a separate piece of paper here, the possibilities, and I'm going to use a tree diagram here. So this is the first coin toss. So the first coin toss can result in either a heads or a tails, and then when you toss the second coin, you know, it's the same thing here. You can have either heads or tails. Okay, so, and it's not necessary to create the tree diagram here to look at all the possibilities. This is a relatively simple problem. So, I mean, you could just list these out, but really what we're looking at here, we could have a heads with a heads, we could have a heads with a tails, we could have a tails with a heads, or a tails with a tails. Okay, and then if you look at the probabilities for each of these, you know, it's going to be a half. We're talking about fair coins, so, you know, it's always a 50-50 chance as to whether you're going to draw a heads or a tails or flip a heads or a tails. And so when you go to look at the actual probabilities of each of these, we're going to actually multiply these. So a half times a half, there'd be 1/4 of a chance that we would have two heads. And again, there would be 1/4 of a chance here that we would have a heads and a tails. 1/4 of a chance here for tails and heads, and then 1/2 times 1/2, again 1/4 of a chance. So if we go back and look at the chart that they're asking here, they're asking something similar, well, but they're kind of organizing it. So the X is actually representing the number of heads. Okay, so what we had here was we had heads, 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 tails, and tails, heads, and then tails, tails. So in our tree diagram, these were actually, you know, I was showing them as being different, but in terms of how they're asking us to count this, these both occur in the situation of just having one head, one heads here. So this is the situation of two heads, and this is the situation of 0 heads. Okay, so the probabilities of those, the tails with the tails, the probability was 1/4. The probability with two heads was also 1/4. And the probability for just getting one head was actually 1/4 plus 1/4, because we had both of these happening. So that's actually a half. Okay. All right, so that right there is our probability distribution. And then they're asking us to calculate the expected value. And the expected value is always taking your whatever your number is, whatever the value of what it is that you're looking at, and multiplying it by the probability. And then we're doing that for each of them, and we're summing them. That's how we calculate the expected value. I'm not going to write out the formula here. You have it there online. You can look up that formula. But this is essentially what it is. I'm going to take 0 times the 1/4, so that's this times that. And then I'm going to take the 1 times 1/2, so that's this times that. And then I'm going to take 2 times the 1/4. And we're just going to calculate that, and that's going to end up being the expected value for the number of heads. And so here we get 0 times the 1/4 is just 0. We have a half, and then we have 2 times 1/4, which is also a half. So a half plus a half is just 1. Okay, and this should make sense to us if we know that it's a 50-50 chance that when we flip a coin that we might get a heads or a tails. If you flip two coins, you should expect one of them to be heads and one of them to be tails. And so we're expecting here, remember X is representing the number of heads here, the expected number of heads here is 1. That should make some logical sense here. Just a note on this, I want to mention just a little bit more. This right here, what we're calculating with these probabilities is, you know, a theoretical probability. There's also, you know, this idea of experimental probability where you're just running an experiment and you see what's going to end up happening. And that can differ quite a bit from what's actually happening in the theoretical. Um, if you take a coin and you flip it 10 times, you might end up with 8 heads. But there's this property called the law of large numbers that says over time, as you flip that coin indefinitely and you move towards infinity with that flip, that the probabilities, the experimental probabilities, will approach the theoretical probabilities. And that's actually true. And so what we do when we calculate these probabilities is we're always working with the theoretical. Okay, that's it for this problem.